Hello Riverdale chemists, this is Mr. Dunbar, and this is a short video to help you prepare for the upcoming Chapter 3 test. So the overall topic was chemical compounds and the bonding that goes into chemical compounds. There are 4 sections to this chapter, so you can see them right here. And you'll recognize the individual topics. So classifying chemical compounds, looking at ionic and covalent bonds, looking at the polar covalent bonds, and then finishing off with nomenclature. So I've shared with you a Google Doc in which I outline the topics from that particular unit, from Unit 3, and also give you practice questions. So you'll notice the first bit of the document includes each of the overall topics. For example, when you're looking at classifying chemical compounds, you also look at the properties of ionic and covalent compounds. So for example, their boiling point or their melting point, the electronegativity of compounds, delta En, and predicting the bond type using the electronegativities. So that's where you're dealing with, let's say, 0 to 0.5, 0.5 to 1.7, and 1.7 to 3.3 for your differences. Okay, so anyway, each of the sections, I've outlined the particular topics that you find in the sections. You can read through the document itself to see that. For the nomenclature section, you have the pink sheet, and I have reproduced the pink sheet in this document. So you have the different types of chemical compounds and the names that go with them. So do make sure that you've looked over these particular topics so that you get most of them. And by the way, please remember that you need to memorize the names and formulas for the polyatomic ions. So you remember those are things like dichromate, sulfate, and so on. So you need to have those memorized. What I've also done is reproduced the Chapter 3 unit review, or chapter review. So there are 9 key ideas that pop up in this chapter. I've reproduced them here, so you can take a good long look at them, reflect on them. There are also a number of key terms that have popped up in this unit. And again, I have copied them from the textbook and reproduced them here for your benefit. I've tried to group them into logical groupings. Take a look at them. Make sure you are able to tell me what the meaning is. So for example, what is electronegativity? Okay. You've also got questions here. I've reproduced the questions. I've eliminated the ones that definitely will not appear on the test. You will be getting answers to these eventually as well. So for example, you have question 2 here. Calculate the delta En for each of the bonds between zinc and oxygen, between magnesium and iodine, cobalt and chlorine, nitrogen and oxygen. So to calculate delta En, you will need to look up the electronegativities for each of these individual atoms. And if we scroll down, you'll notice that there are questions that go up to question 19. It doesn't mean that there are 19 questions. It just means that I've reproduced up to question 19 from the Chapter 3 review. So now if we take a quick look at the textbook, we start off with the first chapter, classifying chemical compounds. And this is where we get to see a nice table comparing ionic and covalent compounds. So for example, at room temperature, ionic compounds are typically solid, whereas covalent compounds can be anything from liquid gas all the way down to solid, and a variety of other properties. There's also the topic of what exactly is bonding, and the covalent bond and the ionic bond pop up in this particular section of the chapter. On page 70, you've got the electronegativity of the particular atoms in a bond. And you'll also notice right here, page 71, you have a nice electronegativities table. So you can use that to answer your questions if you need to. That's page 71 in case you missed it. And on page 72, there is a good visual representation of the periodic trends of electronegativity across the periodic table. There's also this notion of predicting bond type using electronegativity, and that means you have to calculate a delta En, a difference in electronegativities, and then look at this summary of what it means to have different electronegativity differences, so different delta Ens. And we can see here on the right hand side where the difference is minimal, we are dealing with covalent bonds. Towards the middle we've got polar covalent bonds, and at the far left we've got mostly ionic bonds. You have a nice set of PowerPoints that summarize this. I recommend you take a close look at those. Next we have section 3.2, the octet rule, and in this case atoms bond together so that they can get an electron configuration that's the same as that of a noble gas. So their goal is to fill up their outer shell. And a key term here that pops up is whenever you've got atoms that have that outer electron configuration that is the same as that of a noble gas, it's isoelectric. So that's a key term that you definitely need to understand. And the reason we call this rule the octet rule is because all of the noble gases have 8 electrons in their outer energy level. Section 3.2 also covers ionic bonding and the electron transfer that happens according to the octet rule. It also introduces you to the idea of using Lewis structures to show the formation of a bond between different atoms. I strongly recommend that you know how to draw something that looks like either the reaction between sodium and chlorine here at the top, or the reaction between magnesium and oxygen at the bottom. These are both in your textbook on page 76. On page 81 we've got covalent bonding, and that's where we have bonds that consist of pairs of shared electrons. So right here we've got the term pairs of shared electrons. And then we get into the idea of pure covalent bonds. We've also got the idea of diatomic elements. So the pure covalent bond is when you've got an element that bonds with another atom of the same element, and you'll remember the Hofbrinkel diatomic elements. Something that you also need to pay attention to is multiple covalent bonds. We can have double bonds, we can have triple bonds. So for example, in this case we have carbon dioxide. The Lewis structure shows 2 double bonds, one between the one oxygen, or 2 between the one oxygen and the carbon, and 2 between the other oxygen and the carbon. And then in the case of diatomic nitrogen, N2, we have a triple bond between the 2 nitrogen atoms. And on page 83 we have metallic bonding, where the metallic bonds explain why metals are so much more conductive than everything else, and it's because they have these free electrons and this lattice formation that means atoms are not rigidly held side by side. Now section 3.3, that's the final of the, I guess, more theoretical chemistry. That would be the polar covalent bonds and the polar molecules. So we didn't go into great detail here, and you'll remember this is along the lines of having a dipole moment. So for example, HCl, in this case you've got a positive end and a negative end signified by the deltas, delta plus and delta minus. And another great classic example of that would of course be water. Water is a polar molecule. And we also have the concept of lone pairs and bonding pairs on page 88. So lone pairs of electrons are those electrons not involved in a bond, and bonding pairs are. So for example, the shape of a water molecule ends up being this thing called a tetrahedron. So here you can see what water would look like if it had bonds on all 4 sides of the oxygen. But in actual fact, we only have 2 hydrogens attached to an oxygen, so it's a slightly oddly shaped tetrahedron. And you'll notice that I skipped quite a bit in chapter 3.3 It's because we didn't do a whole lot of Chapter 3.3 in terms of stuff that needs to be evaluated. 3.4 is the nomenclature section. You are welcome to look through this chapter. In fact, I encourage it. However, you've also got a number of handouts that cover effectively the same material, and there are some videos out there as well, many videos out there on YouTube explaining the different types of nomenclature. So I strongly recommend you take a look at the review package that you received last class, and also make sure that you practice the questions that have been given to you in this review pack. On page 95, there are some nice diagrams. We've got a Lewis structure that shows how calcium bromide is formed, and we also have a breakdown of how you write the chemical formula for calcium bromide and what each of the items means. And there's this very important concept of valence that describes the bonding capacity of atoms. Bonding capacity meaning how they're going to join together with other atoms. And on page 97, there is a nice table summarizing valences of a number of elements. For the first 20, you can figure it out pretty easily based off of the periodic table. You know it. When you start getting into the transition metals, you start having multiple options for the valence, and that's why you learn the stock system, the Roman numerals in brackets, or the classic naming system like cupric and cuprous. On page 98, there's also a table summarizing the name and valence of common polyatomic ions. Now these are the ones I've asked you to memorize. I do want to point out some things on here. So for example, we've got dihydrogen phosphate, dihydrogen phosphate, and you'll notice that the only difference between the two is that oxygen. So you'll have to remember that naming convention, the ate, the ite, the hypoite, and the per-ate. So as long as you remember those, for example, here we've got permanganate. So that means MnO3 would be, MnO3 minus would be manganate, MnO2 would be manganite, and MnO would be hypomanganite. And then this table also organizes it quite nicely by valence, which is not a bad way of memorizing it, because then by remembering the order in which you memorized it, you also remember the valence. Because I sometimes have difficulties remembering exactly what the valence of a polyatomic ion is. So valence -1, valence -2, valence -3. You can also use a memory aid to help you remember the big 5 polyatomic ions. Nick the camel had a clam for supper in Phoenix. Nick the camel had a clam for supper in Phoenix. So the first letter identifies the polyatomic ion. The number of vowels represents the valence. The number of consonants represents the number of oxygen atoms. So for example, Nick is nitrate. It has 3 consonants, NCK, and 1 vowel, I. So therefore nitrate contains 3 oxygen atoms and has a valence of -1. And on page 99, there is a nice region table, whatever, summarizing how to write a compound using the crisscross method, the crossing over method. And on page 100, there is a summary of how to write potassium phosphate. So we start off with the unbalanced formula, K and PO4, and the recommendation is to put brackets around the polyatomic ions so that you remember that they cluster together. And then above each of the ions, write its valence. So potassium is +1, phosphate is -3, or 3-, and then do your crisscross, crossover, and then write the subscripts. K3, PO4, 1. But we don't need to write 1, so we just write K3PO4. And in case you want to see where the questions on the review package come from, well, they come from your textbook, page 107. So here's the page, the chapter 3 review, with all the questions and all the key terms Now, notice that I have removed some of the questions for the review package that I put together for you. So, please make sure that you take the time to complete the review package and double check your answers against the answer key that you'll be receiving. So, that's it for this brief test review. Do make sure that you're studying for this test. Do make sure that you practice these questions, and do make sure that you check the answers that I've given to you. Good luck, and I will see you succeed on Monday, right?